The next thing we're going to do is linear quadratic elimination. So again, it's the same strategy as linear, except maybe there's a little bit more fun to it. So the very first step is I write one equation underneath the other. Now when you're doing this, because when we're doing the elimination method, we add like terms together, we're going to add all the y's together, all the x squares together, all the x's, and all the constant terms together. So when I'm putting this guy underneath this guy, if I don't have an x squared, I'm going to write a 0x squared, just to kind of hold the spot. So this is what's going to look like. Y plus 0x squared minus x plus 3 equals 0. So all I did in that first step was wrote one equation under the other, okay? The next thing I want to do is figure out which variable I'm going to eliminate. And in order to eliminate a variable, I need to have the same coefficient in front of the variable. Having said that, I won't be able to eliminate the x's because I have an x squared and an x. So I have to eliminate the y's in this situation. They actually already have the same constant term. So in this example, I don't have to scale either of the two equations. Now I need to figure out, am I doing adding or subtracting? Well, if I add y and y, I get 2y. So I know I need to subtract. So y minus y is 0y. Minus x squared minus 0x squared is just minus x squared. X minus minus x is 2x. 6 minus 3 is 3. So I end up with a quadratic. So I know I'm going to need to factor and solve for x. I don't want a negative in front, so I'm going to move it on the other side. So x squared minus 2x minus 3 equals 0. Factor. So x minus 3 and x plus 1. Take each piece, set it equals 0, solve for x. So x equals 3 and x equals negative 1. So the first step was to write one on top of the other. The next step, which I didn't have to do, was to scale the equation. So my next step was to solve for x, and my very last step is to plug this in the original equation and solve for y. So I'm going to do it separately. So x equals 3, y minus 3 plus 3 equals 0, so y equals 0. So that's one of my answers, 3, 0. And this one here, x equals minus 1, so y minus minus 1, so y plus 1, plus 3 equals 0, so y equals minus 4. So one of my answers is negative 1 and negative 4. So that's the final step, is to take what you found here, x, plug it in the original equation to solve for y. So that's how you do linear quadratic elimination. The big thing is to take your time to set it up so that you have like terms stacked one on top of the other.